Today's lesson is lesson 1.3 on square roots. It's part 1 today, and the essential question will be, how can I estimate and simplify square roots?
How can I estimate and simplify square roots?
Yes.
Perfect.
So let's talk about what is a square root?
Yeah.
Well, it says right here, the side length of a square.
Okay, so I'm going to draw a square.
Okay, so let's call it each side 6 and 6. So the side length of a square is the square root of its area. Well, the area of that square is?
So we do 6 times 6, which gives
36.
us 36.
If you take the square root of 36, you will get 6.
6 back.
That's the definition of square root.
Perfect.
A few other definitions or vocabulary. Radical symbol. The radical symbol is right there on the screen in front of you. That is the radical symbol.
Okay.
Radicand, when I refer to that, Miss Boyd and I, there you go. It's the number under the radical.
Gotcha.
Principal root is the positive square root of a number.
So it's your answer.
That's your answer. Correct. Now, if I go down here and I look at, we're going to briefly talk about what a perfect square is.
Okay.
Examples of perfect squares would be 4, 9, 25.
Okay, so like square root of 4 would give me 2.
Yep.
Square root of 9 would give me 3. So they're perfect because they're whole numbers.
Correct. Okay. Now let's say I said, what's the square root of 5? If you went to your calculator and typed in the square root of 5, you are not going to get a whole number. You're going to get a decimal.
Okay.
So that is not a perfect square.
Okay.
When you have a number like that, you have to estimate what that answer is if it asks you to, or use a calculator to get your answer.
Okay, which we're going to do on the next page.
Exactly. So should we talk about more of that on the next page?
We'll just go to the example.
All right. So I'm going to go to the next page, and when I get to the next page, we're going to go to the bottom of the screen, and it's going to talk about perfect squares first.
Okay.
Okay, so here we go. So here's my list of perfect squares.
In case you don't remember.
In case you don't remember any of those. And notice I'd go dot, dot, dot. That means on forever and ever, ever.
Perfect square means if I took the square root of 1, I would get 1.
Yep.
If I took the square root of 4,
I would get 2, and so forth. You do not get a decimal as an answer.
Got it. Okay.
So let's go up to our example 1.
Okay.
If you type in the square root of 55 in your calculator, you will not get a whole number. You will get a decimal. So we need to estimate that.
Okay.
Don't get worried about the negative sign out front. Okay. Basically what that means is in the end, your answer is going to have a negative. Okay. So number 1, when you're estimating square roots, you have to find what are 2 perfect squares, one on the left and one on the right of 55. Okay. If you need to, we can go to our list. And when we look at our list, the 2 are 49 and 64. Okay. So we should put those under radicals and probably attach the negative sign out front just so we don't forget it. Perfect.
I tend to forget those things.
I know, me too. All
right.
So we know the answer is going to be in between there. Well, the square root of 49 we know is 7. So let's give the negative. And the square root of 64 is 8.
And bring on the negative.
Now we ask, okay, is 55 closer to 49 or 64? 55 is closer to 49. Okay. So we know our estimate is going to be closer to negative 7. Okay. So now what we do is we try a couple. Okay. So I'm going to say let's try 7.2. Okay. So if we would square 7.2, okay, and you're squaring a negative 7.2, obviously, so you're going to have a positive. You get your calculator out, you're going to get 51.84. That's close to 55, not quite there. So let's try, I'm going to try 7.4. Okay. And again, it's a negative. If you square that, you're going to get 54.76.
Ooh,
that is darn close to 55. So our estimate works pretty good. We can basically say now that the square root of a negative 55 is approximately equal to negative 7.4. So we should probably circle that.
That's our final answer.
And you can check it on your calculator, and that's what you're going to get. That's how you estimate. Okay. All right, so now we're going to move on. We now have some properties that we're going to talk about. The product property of square roots and the quotient property. Okay. Both of these properties are basically saying that you can either break apart two numbers under a radical
Okay.
and separate them into two separate radicals.
Okay.
Or you can put them together.
Okay.
And you can do that because the index,
oh, yeah.
which is the number outside of the radical, is the same. So you
Okay.
may be saying, well, wait a minute, Miss Young and Miss Boyd, there's no number outside of the radical.
Right.
And why is that?
Never a number, it's
What
always
is 2? Correct.
Because square root and squared kind of cancel each other out.
Yes.
Okay.
So do we want to do a little example
do a quick
here?
Example.
Okay.
So if I had, say, the number 3 times 4, I could also say that it is the same as square root of 3 times the square root of 4.
Yep.
Those are the same things.
Correct.
We could go the other way and
say the square root of 12.
Plug it back in. So if we had square root of 3, square root of 4, now you can just put them both under the radical.
Exactly.
Okay.
Yep.
Perfect.
So quotient works the same way.
Quotient, divide, same thing.
So for example, let's do an example. Let's do the square root of 25 over 5. We know that 25 divided by 5 is 5. So you could divide it and then write your answer as the square root of 5 and be done.
Right.
Or we should probably use the property.
With our property.
Sorry about that. Separate it.
Square root of 25.
Yep. Over square root of 5. And we'll just leave it like that for now. But that's pretty much what we're talking about. That's the property we're using.
Yep. And it's saying you can go backwards. So if you have them both under a square root, you can plug them all under the square root of this one.
Correct.
Okay.
Let's go on to the next screen. All right. So here we go. We're going to go on to example 2. And the goal is this. It says simplify.
So what means break it down.
Yep. And Miss Boyd, what she's doing right now is she's going to break it down. And we're going to think, okay, what two numbers multiply together give me 32? Let's try to pick one that's a perfect square.
Okay. So, and if you can't remember, look back at that perfect square.
Right. So one that comes to mind for me right away is 16 times 2.
Yep. So 16 times 2 gives us 32.
And now the square root of 16 is
4.
The square root of 2, that just stays.
Yeah, because that's not a perfect square, so we just leave it and we get
and there's your answer.
Our answer.
4 root 2. Let's go to the one next to it. Let's break it up into two separate radicals.
Okay.
Square root of 25 over the square root of 36. Well, look at how convenient this is.
Those are both perfect squares.
The square root of 25 is?
It's 5.
And the square root of 36 is?
6.
And we're done.
So that's our answer. So there's no radical in that one.
No.
That's all right.
So now let's go down to example number 3.
Okay.
Now notice here, they have two separate radicals. Okay. So remember what I said on the property, we can actually multiply them together and put the answer under one radical. So maybe we should write 3 times 12, and now underneath that,
gives us the square root of 36.
And the square root of 36 is?
It is just 6.
And we're done.
Nice.
All right, so look at the next one now.
Same thing. Let's put them all under one radical.
Put them all under one radical, correct?
So we got 500
over 5.
Well, we can simplify that. 500 over 5 is just 100.
Right. So the square root of 100 is equal to?
Oh, that's a perfect square again, so it just equals 10.
And we're done.
Nice.
So let's float down to example 4.
Okay.
Now, you know, right away, again, you're doing the same thing. You're thinking of not two perfect squares, one perfect square times another number. To me, I think 16 times 3. But let's say...
I probably wouldn't have thought of that.
Right. So that's why Miss Boyd and I were talking, and she thought of...
Well, I thought just 4.
Yeah.
I know 4 goes into that.
Right.
So 4 times what gives me 18? Well, 4 times 12.
Yep. Yep.
Okay. Well, I know that
the square root of 4 is
2.
But
now I can break this down again.
More.
Because I know 4 goes into that also.
So Miss Boyd is not wrong. She just has to do a little more work, and that is okay. So now we keep going down. You bring the 2 down.
I know that this is, so I bring the 2 down.
Yep.
Because I have to keep bringing it down.
The square root of 4 is
2 again.
Yep.
And we multiply everything in between.
Mm-hmm.
And now I have to bring down the square root of 3.
Yep.
Well, now I can
I'll give her a little more room there.
So now I can multiply my whole numbers together.
2 times 2.
2 times 2 is 4.
Mm-hmm.
And bring down my square root of 3.
Yes.
And that's our answer.
And the reason Miss Boyd can multiply 2 times 2 is they both are outside of the radical.
Yes.
They're no longer underneath the radical. That's it.
Now, as Ms. Young said, she thought of square root of 16 and 3. Well, square root of 16 is 4. When we bring down the 3, same answer.
It's just quicker.
Yep. So,
but that's okay.
If you got it, great. If not, you just can break it down.
But you always have to ask yourself, can I break down the number under the radical more?
Perfect.
All right, next one. Let's separate that into two separate radicals.
So we got square root of 36 over square root of 16. Ooh, and this is nice.
Pretty nice. The square root of 36 is
6.
And the square root of 16 is
4.
Now, this is my question. Are we done? No.
We can simplify that.
Right.
One number goes both into 6 and 4.
2.
So we divide by 2. Divide by 2. And we get 3 over 2. So always make sure you simplify.
Yes, and we used our properties.
Perfect.
Let's go on to the next screen, and here we go to there. Okay.
We're going to skip this one.
Yes, we are going to skip that one.
And we'll do this one in class.
Correct. So let's go to the next screen. However, I need to go back a little bit because I have something at the bottom.
Yes.
Now we're going to talk about rationalizing the denominator. So number one rule is you never, ever, ever leave a radical in your denominator.
So square root. Don't ever put a square root at the bottom.
Yep. Okay. So we're going to get rid of it, and that's called rationalizing the denominator. Okay. And that's really all I'm going to say.
Just get the square root out of the bottom.
Yep, and this is how. Here we go. Example 6 you should be on right now. Notice right now, this is not, we're not done. We have to finish, and we have to rationalize the denominator. How you do that is, Miss Boyd is going to multiply the numerator and the denominator.
So the top and the bottom.
By what's in the bottom.
So
square root of 8
by square root of 8
over square root of 8. And now we can multiply the top and multiply the bottom. Okay. So we know that 2 times 8 is?
16.
Yep, so we have the square root of 16.
Well, we got to keep the square root there.
Yes, we do. And we know that 8 times 8 is?
64.
Correct. Well, look at how nice this is. Because what is the square root of 16?
4.
And what is the square root of 64?
8. And if you remember from last year, anytime you have a square root times a square root, the square roots just cancel and we take the number out. So that's what we did.
But we're not done.
No.
Because they both can be divided by 4.
So divide by 4 on the top and bottom, and you're left with 1 over 2.
And there we go.
Okay.
Good. So now the problem next to is we have square root of 7 in the denominator. Same thing. We're going to multiply the top, and we're going to multiply the bottom by the square root of 7. Here's where it can get tricky. Notice in the top, the only two numbers you can multiply together are 5 and 7.
Yes,
the
because
3
they both have square roots.
Correct.
So we just write the 3 again.
The 3 just comes along for the ride. So 5 times 7 is 35. All over the square root of
7 times the square root of 7,
which is 49.
Those cancel.
Oh, yeah, that's true. Yes, we can. And we're done.
Sweet.
We can't reduce.
Nope.
And that's it.
Right.
Now, one thing I want to mention, though, some of you may say, well, wait, 35 divided by 7, that's 5.
Oh,
cannot do that.
Because this is under the square root.
Correct.
So you can't divide those.
You cannot divide those.
You could divide these two, but it wouldn't be nice. So we're just going to leave it.
We're going to leave it alone. All right. So I think we're done.
Class. Yeah.
So let's go forward a screen here.
And here are your video questions. See you
tomorrow.